Given that 0.k bar represents a decimal in which the digit k repeats without n, then what is the value of this expression? And in that expression we have this 6 with a bar over it, which means the 6 is going on forever. We know that the 3 is going on forever. 0.3333 going on forever is 1/3. And this is double that, so in fact this is 2/3. So that's the first thing we need to know, that 0.6 repeating is the fraction 2/3. Let's just look at that denominator. That denominator, which is 0.5 times 0.6 bar squared. 0.5 is just 1/2. And then we found here that 0.6 bar, that's 2/3, so that's 2/3 squared. So 1/2 minus 2/3 squared. We're just looking at the denominator. Well, of course, this is 1/2 minus, when we square a fraction, we square the numerator and the denominator. That's 4/9. Then we need a common denominator. Common denominator would be 18. So multiply 1/2 by 9/9, it becomes 9/18. Multiply 4/9 by 2/2, it becomes 8/18. When we subtract, we get 1/18. And so the denominator equals 1/18, and of course if we have 1/1/18, the reciprocal of 1/18 is 18. And that's answer choice E.
To begin, let's get a better idea of what set k looks like. Now, all of the fractions in set k have this form, where x is a positive even integer less than 20. So x can equal 2, 4, 6, 8, all the way to 18. So if x equals 2, then x plus 2 will equal 4. If x equals 4, then our denominator will be 6, and so on, all the way to x equals 18. Now we want to know the product of these fractions. However, before we do any multiplying, notice that we have a 4 here and a 4 here, so we can cancel them. Similarly, we have these two 6's, which we can cancel. We can cancel our 8's, our 10's, and so on. Now when we multiply, we get the product 2/20, which is equal to 1/10, which is equal to B.
So astronomers determine that a certain square region has an approximate area of this. So this is the area, and we want to know a side of the square. So essentially we have to take a square root of that number. Well, very interesting. Yes, we could use a calculator, but think about it this way. The problem says approximately, which means that we are allowed to approximate a bit. So I'm going to say that 2.4 times 10 to the 7th. First of all, we could take out a factor of 10, and that's 24 times 10 to the 6. And 24 times 10 to the 6 is very close to 25 times 10 to the 6. Well, that's interesting because 25 is a perfect square, and 10 to the 6 is a perfect square. The square root of 25 times 10 to the 6 is 5 times 10 to half of 6, which is 3. And so since this is very close to this is a good approximation for the square root. Answer choice A. One of the virtues of scientific notation is it allows us to separate the numbers from the variables. So what we're going to do is we're just going to perform these two as acts of division separately. We're going to have 3 divided by 6, and then over here we're going to have 10 to the 15th divided by 10 to the negative 7. Well, 3 divided by 6 is 1/2. I'm going to write that as a decimal, 0.5, times, and then x to the 15th divided by x to the negative 7. When we're dividing by negative 7, that's the same as multiplying by 10 to the positive 7. So 10 to the 15th times 10 to the positive 7, that would be, we just add the exponents and get 10 to the 22nd. Now this right here is not proper scientific notation because the number in front has to be between 1 and 10, and this is less than 1. And so what we're going to do is we're going to take out a factor of 10. So that 10 to the 22nd, we're going to write that as 10 times 10 to the 21st. We're going to multiply these together. 0.5 times 10 is 5. So we get 5 times 10 to the 21st, and this is answer choice C.
All right, let's begin by finding the value of e. Since e does not equal 0, we know that e must equal 1. We know this because the sum of any two two-digit numbers can never be greater than 200. Now we'll find the value of f. We know that f equals 0, and we can reach this conclusion in several ways. One way is by process of elimination. For example, we know that b can never equal 0, because if b equals 0, then d and g would have the same value. But the question tells us that each variable has a different value. For the same reason, we know that d cannot equal 0. We know that g cannot equal 0 because none of our answer choices is 0. A and c cannot equal 0 either. If either of these equals 0, then we would have a one-digit number plus a two-digit number equaling a number over 100. And this cannot happen if our two-digit number is less than 70. And our two-digit number must be less than 70 because we only have the numbers from 0 to 6 to work with. So since a, b, c, d, and g cannot equal 0, we know that f must equal 0. From here we know that b plus d must equal g. Well, there are only two possible cases that meet this criterion. Either b and d are equal to 2 and 3, and g equals 5, or b and d are equal to 2 and 4, in which case g equals 6. Let's check out the second scenario, b and d equaling to 4, and g equaling 6. If this were the case, then a and c would equal 3 and 5, and notice here our sum does not equal 106. So b and d cannot equal 2 and 4. So let's check out our second case, b and d equaling 2 and 3. If this were the case, then g equals 5, and a and c will equal 4 and 6. Notice here that our sum is 105, so these must be the correct answers. So g, in fact, in this case, equals 5, so our answer is D. A good approach to this question is to convert each of our decimals into fractions. Now, before your test day, you should be familiar with all of these conversions as well as others. Let's begin with our numerator. 1.3333 is approximately equal to 4/3. Our second decimal is approximately equal to 2/3, and our last decimal is equal to 9/8. We can convert the decimals in our denominator as follows. We're now ready to find our products. The product of the fractions in the numerator is equal to 1, and the product of the fractions in the denominator is equal to 1/2. And this evaluates to be 2. So our answer is D. Okay, let's examine each statement and determine whether or not it is valid. Statement 1. We can show that this statement need not be true through counterexample. If x equals -10 and y equals 1, we end up with the inequality 9 is less than 1. This, of course, is not true, so statement 1 need not be true. On to statement 2. This statement need not be true as well. We can show this through counterexample with x equals -3 and y equals 5. Here we end up with the inequality 2 is less than 0. This is not true, so statement 2 need not be true. And finally, statement 3. Well, here we know that x is negative and y is positive. And we know that the product of a negative number and a positive number is always negative. In other words, it is less than 0. So yes, statement 3 is true, so our answer is B.
Q, R, S, and T are integers on a line. They're on the number line. The distance between Q and R is twice the distance between R and T. So this is 2R, 2D, and this is D. And then we're told that S is the midpoint of RT, and then which could be the distance from Q to S. So let's think about this distance here from R to S. We could call it D over half, but let's just call this L. That's L, that's L. This is 2L, and Q to R is twice of 2L, so that should be 4L. Now the distance from Q to S, that would be L, 4L plus L, that would be 5L. Now, what do we know about L? L is the distance between two integers, so it has to be a positive integer. That's all we know. L could be any positive integer, large or small, but we notice that this distance is 5 times a positive integer. In other words, it must be a multiple of 5. Well, that's very interesting. It has to be a multiple of 5. The only answer choice that is a multiple of 5 is answer choice C.